Welcome to the deep dive. Today, we're zeroing in on something really vital in the world of making software: test coverage. Now, if you're tuning in as a learner, maybe you're prepping for a tech conversation, trying to get a better grip on software quality, or you're just, curious, our goal is to unpack this for you quickly but thoroughly. No need to wade through loads of technical jargon. We're really aiming for insights you can actually take away and use.
Exactly. Think of this as your shortcut to understanding test coverage. Our mission today is pretty straightforward. We want to really get to the heart of what test coverage is all about, why it plays such a critical role in software development, the different ways development teams actually work to achieve it, and importantly, where its limitations might lie. And we're pulling all this directly from our source materials, trying to boil it down to the essentials for you.
Okay, great. So let's dive right in with the fundamental question. What is test coverage? Our sources formally define it, let's see, as a metric in software testing that measures the extent to which testing has been performed. It looks at which parts of the program's code are executed and whether the various pathways, the branches within that code, have been explored during testing.
And maybe to put it a bit more simply, it's really about making sure your tests are actually doing what they're supposed to do. Testing the code you've written, it gives you a feel for how much of that code is being put through its paces by your testing. What's really interesting here is what understanding your test coverage actually lets you do in your development process.
Precisely. It's not just about hitting some arbitrary number. It actively helps you spot areas of your software's requirements that maybe haven't been touched by your current tests. And that then guides you in creating more targeted, more effective test cases. Plus, it gives you a tangible way to measure, well, at least indirectly, the amount of testing you've done. And here's an interesting angle. It can even help you identify tests that aren't really adding much value, unnecessary tests.
Which is key for efficiency, right? You don't want wasted effort. So the natural next question is, how do teams actually get this test coverage we're talking about? How do they achieve it? The sources highlight several pretty important approaches.
Right. And it's not just about running automated tests and seeing what lights up, is it? Our sources really emphasize the value of what they call static review techniques, things like, peer reviews, formal code inspections, walkthroughs, getting eyes on the code early.
Absolutely. It's about different perspectives on the code, on the requirements, even before you run much. Another really crucial method is taking those unexpected bugs, those ad hoc defects that always seem to pop up, and actually turning them into solid, repeatable test cases. If something broke once,
You want to make sure it stays fixed.
yeah, exactly. You need to test for it going forward. And then, of course, we get into the more, let's say, technical ways of achieving coverage.
Yep, like at the code unit level, unit testing. That's where you often use automated code coverage tools. These tools can pinpoint exactly which lines of code, which specific branches within the code have been run by your automated unit tests.
Right.
And then looking bigger picture, at the overall software functional test coverage, that's where good test management tools become really essential for tracking what's been tested, what hasn't.
Makes sense.
Yeah.
So, okay, why invest all this effort? What are the real tangible benefits of making sure you have solid test coverage? The advantages seem pretty significant when you tie it back to the main goal, building high-quality software.
You got it. For starters, it gives you a much higher degree of confidence in the quality of your tests themselves. If you have good coverage, it suggests your tests are actually reaching and, exercising a good chunk of the code. It also makes it way easier to see exactly which parts of the code were changed for a specific release or maybe a bug fix. That lets you focus your next round of testing much more effectively.
And maybe most importantly, it shines a light on those paths within your application that just haven't been tested at all. This kind of proactive approach is really key to preventing defects from slipping through the cracks and hitting the end user. That whole situation people call defect leakage.
Oh yeah, definitely something to avoid. Releasing a feature and then finding out something core that nobody tested is now broken. Nightmare scenario.
Totally.
Beyond that, good test coverage actually helps keep the project on track. Time, scope, cost, all that. By catching potential issues early, you avoid costly rework later on. It really shifts the focus towards defect prevention.
Right, being proactive rather than reactive.
And it's even more comprehensive. Test coverage helps you kind of map out all the decision points, all the different ways the code can run within your application.
Which, as our sources point out, makes it a lot easier to spot gaps. And not just gaps in your test cases, but potentially gaps in the requirements themselves.
Ah, interesting.
Yeah, and it helps find defects really early at that very granular unit code level. It's a pretty holistic strategy for building quality in from the start. Now, it's easy to hear test coverage and code coverage and kind of think they're the same thing, but there are some important differences, right?
Yes, good point. Let's clarify that. Our source material gives a helpful comparison. Code coverage specifically focuses on the application's code while it's actually running. During runtime, it's very much about monitoring what your automated tests are doing, which lines they hit.
Right. Whereas test coverage is broader. It's more about the entire test plan. It gives you that overall picture, how thoroughly has the application's code been tested by all your testing activities.
Exactly. And code coverage even has these more specific subtypes, doesn't it? Like statement coverage, condition, branch.
Yeah, toggle coverage, FSM coverage, different ways of slicing how the code itself is executed. Test coverage doesn't usually break down like that. The main goal for code coverage is often understanding and maybe optimizing your automated tests. Test coverage gives that higher level view. How well has the whole application been exercised?
Okay, that makes sense. So how do you actually put a number on this? How do you calculate test coverage in practice?
The formula they give is actually pretty straightforward.
Yeah.
You basically take the number of lines of code that your tests execute. You divide that by the total number of lines of code in whatever part of the software you're looking at, and then just multiply by 100 to get a percentage.
Simple enough. Our source gives a clear example too. Like if you have a piece of software with, say, 500 lines of code total, and when you run your tests, only 50 of those lines actually get executed, then your test coverage is 50, 500, 100, which is just 10%.
Precisely. It gives you a number, a quantifiable view, though maybe a high-level one, of how much code your tests are actually touching. Now, to make this a bit more real, less abstract, our source has a couple of nice practical examples.
Yeah, I found these really helpful, actually. The first one talks about testing a knife. You could just check if it cuts vegetables, okay, right? Basic function, that's some coverage. But true test coverage would go further. It would also look at things like, is the knife comfortable? Is it safe for the user to handle? It goes beyond just the main job it's supposed to do.
That's a great point. It's about the broader user experience, other potential failure points. The second example was about a simple Notepad app. Sure, you need to check the basics, typing, saving, opening files, they have to work.
Standard stuff.
But comprehensive test coverage would also dig into how that Notepad app interacts with other apps. Is the interface easy to figure out? And crucially, can it handle weird stuff? Like, what if the user does something unexpected? Does it crash? Does it lose data?
Right, like trying to paste a massive image into a plain text editor or something bizarre. What happens then?
Exactly. Those examples really hammer home that test coverage isn't just ticking off a feature list. It needs a more holistic view. How will this software actually be used? What could go wrong?
Okay. But like any metric, it can't be perfect, right? Test coverage must have some downsides or limitations we should know about.
Absolutely. And the source does highlight this. One of the key limitations is that a big part of getting good test coverage is still, well, pretty manual. That first step, really analyzing the requirements, figuring out what needs testing, and then designing good test cases, that takes a lot of human effort and thinking. There aren't always tools that can just automate that whole critical design phase.
And that human element, that naturally leads to another potential issue, doesn't it? The possibility of just errors in judgment. When you're trying to count features, measure them against tests. There's bound to be some subjectivity in how you do that.
For sure. Which really means that while test coverage gives you valuable data, it's not some kind of infallible guarantee of quality. You could, in theory, hit a really high percentage, like 95% coverage.
Sounds great on paper.
Right. But you could still have critical bugs hiding if your tests weren't designed well. Maybe they missed the tricky parts, or you assumed something wrong about how users would interact with it.
Okay, that's a crucial caveat. So let's try and wrap this up then. We've taken a deep dive into test coverage. We understand it's this key metric, helps us gauge how much of our code is actually being tested. We've looked at the benefits, better quality, catching defects early, helping manage the whole development process. We've also cleared up the difference between test coverage and the more specific code coverage, and even seen the simple formula to calculate it. It's clearly a pretty powerful tool for software teams.
Indeed. It offers valuable insights, highlights areas needing more attention. It tells you about the breadth of your testing. But, as we've just discussed, it's important to remember those limitations. It relies heavily on that initial manual work of defining what to test. And human judgment always plays a role, which can affect how truly effective it is. It doesn't guarantee depth in the same way.
Right. So here's a final thought for you, the learner, to maybe mull over. Given that test coverage, even though it's valuable, doesn't catch every single bug, and it's ultimately only as good as the tests themselves, what other strategies, what else do you think might be absolutely essential for ensuring software is truly robust, truly reliable? It's a question that pushes us to think beyond just this one metric, maybe towards a more holistic view of quality assurance. Thanks for joining us for this deep dive. CTSS Academy Podcast, where ideas ignite and futures forecast. Dive into realms of wonder vast. CTSS Academy Podcast.